In around 1997, I made an Asteroids game using C++, and I made it as first of all as a Windows NT screensaver. And this is the Asteroids game here. And I've decided to open source the source code for this. I think I've open sourced the previous version of this as Python code, and maybe even some other code as well. And the actual source code is in my GitHub page, which is in the link is in the description of this video. In this video I'm going to show how to build this Asteroids game on Linux, on Windows and on Apple OSX, and see it running on all of those platforms looking exactly the same. In previous, like I said, previously I've made it on different platforms, and one of the platforms that I ported it to was also Android, so I've got the actual game here which can be played just as it can on the Windows and Linux and Apple OSX. So to make the actual game on a Linux system, the actual instructions of what's required and everything are in the README file, but it's as simple as typing make on Linux, and it will actually build the actual game itself. And then once it's built, which doesn't take long because there's not much source code there, just type Asteroids to start the game, and it starts up. So to make the game on an Apple OSX platform, just type make and then Apple to say it's the Apple platform. It builds for a second, and then just to run it, you do the same as on the Linux platform, just run Asteroids. It comes up exactly the same. So to make on a Windows system, I'm using MinGW, and to actually use it I need to set up the path, add the path to MinGW to the path of that's in my command prompt. So I just do that. I've got a batch file which does that, and that just adds the path. And then I just type make and Windows to specify I'm making it for a Windows platform. And it just takes, again, about the same time as it takes on the other platforms to actually make the executable. And then when that's done, I just type asteroids.exe, and it starts up and plays exactly like it does on the other platforms. So before I go over the source code, I'll just take a little overview of the way the classes are set up in the actual application itself. So in the center, there's in magenta the Asteroids main application, which is just an application loop, and it goes through different states, and it gets user input and updates a frame of the actual animation of the game. And then the classes, so below, to start off with, there's number class at the bottom of the display. And that has two instances in this game. So one of the instances is a high score, which it keeps, which is owned by the main application, and the other one's the player score, and that's owned by the actual ship of the player itself. And then at the top of the display there's a similar class, which is a text class, and there's only two instances of that in the game. One is to display insert coin, and that has an attribute flash in set to true. and then one to display game over when the actual end of the game comes about. And then on the right hand side of the display we've got the rock class, Astro Rock, and there's an array of those, and at the start of the game there's maybe 4 or 5 instances of that actually inactive, and then when you shoot a rock, the actual currently active rock stays active but reduces in size unless it's the smallest, in which case it finishes itself off. But if it reduces in size by 1, then it also creates an additional active rock in the array of rocks. So you've got 2 smaller rocks, and in turn those get split into 2 smaller rocks as well when they get shot. And then on the left hand side of the display there's the UFO class, and there's only one UFO, and it comes across the display randomly at a random time. And that UFO class has 1 instance of a shot class, so it can only shoot 1 shot at any time, and that gets shot in a random diagonal direction. And then the final class, because there's not that many classes in this actual game, it's a very simple game and not much source code, so it's easy to get your head round. The final class is the actual player's class, the Astro ship, the ship, and that has 3 lives when you start off the game, and it has, like I said earlier, it has an instance of the number class in it which keeps the player's score, and it also has an array of Astro shots as well. So whereas the UFO class only had 1 shot, the player's ship can shoot a series of shots, and it takes care of doing that within the actual Astro ship class itself. So I'll go over the source code. So this first file is the main source code file, and at the top I've made the wave files that it uses in SDL for the game sounds, made them global because different objects want to use those, and I load them in their single sort of routine. So the main application actually owns those. Then there's the game objects which I set up here, and these are all the game objects which should actually use. So that the ship, the UFO, an array of rocks, a high score, and the text for game over and text for insert coin. This first rock is the number of rocks at the start of the level. So for the first level I think it's 5 rocks, and then each level after that it goes up by 1 rock, and next rock is the next rock that's available to be created. So when you shoot a rock and it splits in 2, the next rock points to the next rock which is available for the new rock instance. Then on Windows, Windows has a special main entry point itself, so I had to put that in, and all it does is call into the standard main entry point for C++ or C. And in the main routine I set up the SDL events or SDL variables, I should say, sorry, for the display and for the event queue. So when I'm reading keys for the user or when I'm outputting to the display, these are the things which are used. And this is the size of the window which is created for the actual game. And because when you saw at the very beginning of the video, I've made a version for Android, and the window is much smaller on Android, you should be able to just change the values of these, and it should automatically create a window the correct size and operate the game correctly within that window. But I haven't tried changing that recently, but certainly in the past that should have been active and able to just change the values in there. Then I set up a random seed depending on what time the application has been started at. So each time you start the application you get a different game. Otherwise it will just use the standard seed, and you just get the same game every time you start the application. Then it initializes the SDL environment and creates a window, and it gets a renderer for the window and sets up that renderer for the correct width and height of the window. It loads in the audio files here. So like I say, the audio files are all owned by the main application. It just loads them up in a single place. And then it sets up the audio device for SDL. And I've used the very simplest method of using audio on SDL. So if you remember when I demonstrated the Android game, it could actually overlay sounds over the top of each other. So every time it wanted to play a sound, it would just overlay it on top, and so you could merge all the sounds in together. Well, this very simplest way of using the SDL audio, it only plays one sound at a time. So I have to prioritize the sounds as to what's the most important to be heard. And then it sets up the game components for the very first time, so that it sets up the location of the text that gets displayed and the color of it, sets up the location of the high score, sets up the ship position and the UFO, and all the initializes all the rocks so that it doesn't just like crash when you start the first game. Then we go into the main loop. So this is the infinite loop for the game, and for each frame which is displayed does a delay of 50 milliseconds, and then it displays the frame, which is a function at the bottom of this file, so I'll go through that in a second. Then it goes into the event loop. So all it's doing in the event loop is looking for key presses, and it's one other event, which is when the window is closed. So if the window is closed, it sets up a flag to exit the application. And then it looks for key up events. So the thrust and rotate operations, when the key is pressed down and held down, thrust is active for the whole period until key up is released, until the key is released. And then it unflags. So this is unflagging the thrust is being pressed, or unflagging the rotate left or rotate right. And then when the key down has been pressed, if it's the escape key, then it quits the application. So you can quit the application either by closing the window or pressing the escape key. If the one key is pressed, then it will create a new game, but only if there isn't a game active at the time. So if there's still lives active for the ship, it won't create a new game. It's only if there's no lives active for the ship. And then when the new game is created, it just sets up all the objects to be in their initial positions for the start of the first game. Resets all the rocks to make sure that you've only got the rocks that are active at the start of the first game. And like I say, first rock is the number of rocks at the beginning of the game. And then when left shift or right shift is pressed, it makes the ship shoot, the player's ship shoot. And when the up key is pressed, for the cursor up key, that is, it activates the thrust. And when the cursor left key is pressed, it rotates left. Cursor right key pressed, it rotates right. And when the down press key is pressed, then the ship goes into hyperspace and then randomly appears somewhere on the display about a couple of seconds later. And that loop just keeps going around until the exit flag has been flagged. And when that's been flagged, it closes the audio device. It frees up all the memory for all of the wave objects. It closes the window, quits the SDL environment, and then comes out of the application and returns to the operating system. And so this is where each frame is displayed. So it does a few things in this as well as display the frame. So if the thrust flag is set, then it tells the ship to thrust, and that will change the velocity of the ship depending on which direction the ship's being pointed. If the rotate flag is set, then it will rotate left or rotate right depending on which of those flags is set. It tells the ship to move one unit for this particular frame. So when the ship moves, it takes into account what the velocity of the X and Y directions are, and it moves the ship in the appropriate direction. And the same with the UFO, it moves the UFO, and the UFO randomly changes direction as well. And then it checks for collisions, so it checks to see if the ship has collided with the UFO, and if it has, then it tells the ship it's crashed. And it checks to see if the UFO shot, so the UFO shoots one shot at any particular time. It checks to see if the UFO shot the ship, and if it has, it sets the ship to be having crashed. Then it see if the UFO is active. It checks to see if the shot, so it checks each shot of the ship. So the player ship can shoot multiple shots. It goes through each of the shots that the ship can shoot and checks to see if it's actually shot the UFO. And if it has shot the UFO, it adds 100 to the score. And it destroys the shot which shot the ship, shot the UFO. And then it checks to see if rocks have collided. So it goes through each of the rocks, and it has this flag as well because it checks to see if a rock has been found. So if a rock is not inactive, then it flags that a rock has been found. And the reason it keeps this flag here is that after it's checked this, if no rocks have been found, then it means it's the end of that particular level and it has to start a new level. So it's just flagging that there because it's convenient to do it in the same loop that it does to check the collisions with the rocks. And then it checks if the ship has collided with each rock, and it crashes the ship if it has, and it splits the rock into two as well. So the existing ship, the existing rock will get smaller in this function where if it's collided, and then it gets the size of that here where it creates a new rock to create a rock of the same size. And then it checks to see each shot of the ship again to see if it's shot any of the rocks, and if it has, then it adds a score of 1 plus the rock size times 5. So the rock can have 3 sizes. It's large, medium and small, and it destroys the shot which shot the rock, and then it splits the rock that got shot into 2 again. But if the rock is of an inactive type, then it will just there will be no more created rocks. So that rock will be destroyed. And then, because it's convenient in this loop, because we're going through all the rocks anyway, to move each of the rocks as we go through this loop. And here, like I was saying, that flag, if no rocks have been found, then it creates a new level, and it plays this sound to indicate a new level has been started. It adds 1 to the first rock, the first number of rocks in this particular level. So this level will start with 1 more rock than the last level, and then it creates each of the rocks which need to be active for the start of the level. And then if there's no more ships, then it displays the game over text. And when the game over text, because it only displays for a certain period of time, when it goes invisible and there's no more ships, then it displays insert coin flashing text. And then this is where we display all of the game objects. So each of these objects has a draw function, and we just tell each one to draw, and we go through all of the rocks, and they will only draw the rock if it's active, but all I have to do is call this draw function, and the draw function decides whether the rock is active or not. And then after all the things have been displayed on the frame buffer, which is about to be displayed, because the frame buffer doesn't get displayed until you call it to render the frame buffer. And then we set the background color and clear the next frame, ready to actually draw onto the next frame. So the next class I'll go through will be the number class. So this is very similar to the text class. It's a very simple class. It holds its own value. So for the instance of the score, this will be the score. For the instance of this class for the high score, it will be the high score. It holds its position on the display, and it holds a scale value. So the scale is the size of the writing. So you can make the writing, scale the writing up or down, depending on how big you need the actual text. And then there's a function to draw the text, and it will just go through the current number, and it sets the color that's required, and it goes for each of the digits. So there's possible up to 10 digits are displayed for each number, and it does a divide by 10 to decide what the remainder is for this particular digit, and it goes for each of the digits in the number and just renders them on the display using this draw lines. And the draw lines just draws a set of lines which are defined in the set location. So when you change the location of the number, it actually defines the numbers here, because It doesn't do this in the constructor for the numbers because you can set the scale or the size of the actual text which is being displayed, and so you might want to change the size of the text when you actually change the location of the text on the display, if you want to change the location of the text on the display. So this is where it defines what lines draw the number 0, what lines draw the number 1, and so there's just like an array of numbers, and the value is here as to which number is being defined, and that's just a set of lines which, like I say up here, you just have to pass it the value here of the digit, and it will, SDL will draw all the lines within the particular array element that you want to be drawn. And then there's just get number and set number to get and set the value of a particular number. So I'll go for just one of the game object classes because they're all based around the same principle and the same member functions. Some may have a few more member functions than others, so the ship will have a few more because it does a few more things, but the rock one is a nice basic one to go over, and once you get the concept of how this has been laid out, then it will apply to the other objects as well. So I get the external variables for the wave files because this object has a wave file associated with it. So the constructor in this case just sets up the basic values of the actual object, and also defines the actual shape of the object in lines in the same way that you saw just a minute ago in the number class where all the numbers were defined. But in the game objects it just has to define them in the constructor because it doesn't rescale them at any stage. Because it's for the rocks, even though they have 3 sizes, the actual sizes of the rocks are set in the constructor as well because they're static sizes, so, and they're set to inactive by default. And then there's a draw function, and that just does like you saw in the numbers. It sets the color and just draws the lines that are required to be drawn. And then there's a move, and that just moves the object around the display. Also checks to see if it's gone off the display, and if it has, then it wraps it around to the other side of the display in both the X and Y axis, and it adds the velocity to the X axis or velocity to the Y axis for this particular movement. And set area, this is the initial, when you want to place an object on the display, it calls set area, so that it places it where you want to place it in the size you want to place it. And after it's been set, then you don't need to reset any of this information. It just then moves around the display using the move member function and the draw member functions to draw it. And then there's a member function which checks to see if a collision has been made. So you pass it in the area of the display you want to check if it's collided with, and it operates on whether or not it's collided and does whatever it needs to actually do. Depending on whether it's collided or not, and it returns a true or false as to whether or not it's been collided. And when you destroy an object, it sets the object into an inactive state and places the object off the display. So this hyperspace is where the ship goes when it's in hyperspace and goes off the display. And I just use the same variable to set any other objects off the display when they're inactive. And then there's just access functions for getting things like size, X position and Y position.